Thanks, everybody. Thanks for joining the next webinar in our series, this one on inline serviceability. We're here today to introduce an exciting product from ValvTechnologies, our metal-seated ball valve. And with me today is Richard Laucom, and Richard is responsible for developing the technical specifications across North America for high-performance severe service isolation valves. He joined ValvTechnologies in 2007. And his responsibilities at that time were global projects, and then subsequently that led into leading the design team, and is now involved in developing forward-thinking visions for emerging technologies. Previously, Richard held positions at IMI in the field of fluid control, and he graduated from Loughborough University with a Master of Engineering and Management, and he holds a diploma in industrial studies, postgraduate certificate in management, and is a member of the Institution of Engineering and Technology in London. So thank you, Richard, for being here today. My name is Dave Friesen. I'm the president of CGIS, and also held the role of sales guy for many years at CG. So very familiar with ValvTechnologies product offering. In terms of housekeeping for today, this is intended, while we're going to do most of the talking, it's intended to provide you as much data as possible and information. So if you have any questions at all, please just pop those into the chat. Sammy is going to continue to monitor that throughout, and there will be questions at the end of the discussion. And then obviously you'll have our contact information as well if there's anything post-presentation. Just to start, I want to talk a little bit about valve characteristics, and in particular, this is something that's been emerging over the last number of years, and CGIS has done a ton of work, in particular with MSS through this area of understanding valves and their purposes within the world. So we try and define the valves in three different criteria. So there's a general purpose valves, fit for purpose valves, and severe service valves. This, we're happy to report that MSS tells us this will be published in the coming months. It's been about a 6-year process for Ross Waters, who was originally led this conversation. But we break the valve down in a number of areas. So moving from left to right, when we talk about the consequence of valve failure, general purpose valves are quite often used in simple applications. So if the valve fails on an airline, is it a big problem? Probably not. If we talk about the consequence of valve failure on a category M service, then that could be obviously is very serious. So we look at the consequence of failure, the long-term isolation required, how critical that is, the process data that's required to supply, i.e., if we got a critical service valve, then we're going to ask a whole lot of questions. And anybody that's dealt with CGIS for a long time will understand that we typically ask a bunch more questions than most folks. If it's a simple application, then quite often we can get away with a 2-inch class 150 carbon steel valve. That would be the extent of the data we would require. What's the typical purchase price? Typically, a more severe service valve is going to cost more because there's a whole lot more engineering, metallurgies, specialized coatings, et cetera, that might be used. The availability, again, the continuum from stocked on the shelf for your general purpose product all the way through a made to order, specially designed product, more typical of severe service world. And then cost effective to repair or replace for those general purpose valves. You know, if you got a $100 butterfly valve, the cost to repair it is probably prohibitive. If you've got a triple offset metal seated valve, then it's more likely that you're going to spend the money to repair that valve. So those continuum are how we try and look at valves and where they fit in the world. Next, Sammy. So at this moment, we want to introduce the ValvTechnologies product. So anybody that's used the V1 series over time, and particularly we're talking about high pressure steam, but it's used a lot in various gas services and whatnot as well. What we've been able to sell over the years is this reduced downtime and seamless service. So the valve has quite literally have sold thousands of these valves where they've gone in service and they've been in for 15, 20 years. It's not uncommon at all. But typically these valves are weld in place. And the one challenge that we've had over the years, or if you want to talk to a customer that's used the valves, is if there's ever an issue, the reality of having to cut the valve out is problematic. It's costly. And so from that standpoint, we're super excited about this game changer with a plug and play serviceability that ValvTechnologies has introduced in this new V1R product. With that, I will turn it over to Richard.
Thanks, Dave. Really appreciate the good introduction there. And firstly, good morning or good day to all the people on this webinar. And thank you for joining us. And as Dave was saying, ValvTechnologies has been known for its range of products over the last 30 to 35 years. And many of you may have used the V11s. It's a high-performance weld-in-place valve that has seen typically service lives of between 15 and 20 years in steam. And it hasn't been unsurprising to see one of these valves last even 25 years. But like with anything, time changes, things move along. And what we're seeing is that more and more, the time to do repairs is now a major factor. In the past, OEMs and manufacturers such as ourselves haven't really put much thought into how valves or the pieces of equipment could be maintained up until now. And so we're pleased to introduce the V1R. So we now have two champions in the room. And really the purpose of this is to give you, the customers, a choice. So the choice that we're offering now is a plug and play capability, one that is able to be serviced inline. And the difference really here is that we're trying to reduce time in the field and also money in the field when it comes to lost production. With the V1R, we do have less customization. There's a fair bit of standardization of components that go into it, but we're still offering the V1R for those applications where we need to have a degree of customization. So really, we have taken everything that we've learned on our successful range of the V series over the last 30 to 35 years, rethought it, used most of those technologies, but made it simpler to repair in the field. And so why would we want to do this? And that's really down to the fact that time is money. Nowadays, whenever there are turnarounds or outages, we can define the loss of production perhaps in dollars per hour or even dollars per second, depending on the particular site. And so the longer any plant is down, the more costs there are incurred, mostly due to loss of production profits at that point. And so with this increasing commercial focus, the aim is to increase run times as long as possible and to reduce those maintenance outages. So of course, repairability now becomes into focus. And it turns out that there are ways to reduce maintenance periods. And this is what the V1R is all about. We're here to make things quicker and easier, specifically in the field. So let's compare what the V1R is all about versus a standard fit-for-purpose valve. Typically, an engineered valve costs more. So if we look at the blue dots there, we can see that an engineered valve does cost more than a fit-for-purpose valve. Typically, installation costs may even be the same, especially when we're talking about welded-in valves. And it depends on the metallurgy that we're talking about. But perhaps the biggest difference between the two is the life cycle maintenance costs. What the V1R proposes is to reduce the overall maintenance costs, and we'll show you why throughout the rest of this webinar. But the big thing that we want to highlight here is that when we look at maintenance costs, the V1R is there to reduce that over its lifetime. So how is this possible? Well, let's start off with welding to begin with. When it comes to certain chromoly materials such as P91 or P22 pipes, there is the added step, not just of welding them into place, but there's the added step of post-weld heat treatment. And secondly, when you're welding in such high-performance alloys together, the welding codes must be adhered to. So we're talking about qualified, experienced personnel in order to do that particular job. And so one of the things that post-weld heat treatment does is it actually increases the length of time to install a new product. So not only does the time go up, but the labor costs go up. And of course, the actual maintenance duration goes up as well. We see these types of materials in power stations or in steam plants. But the other factor to consider too is that more modern power requirements often require that plant to cycle more often. So it depends which particular province you're in, but where renewables are increasing, and whether that's wind power, geothermal, or even solar power, when it comes to fossil power generated by standard steam plants, these plants, which were originally designed for base loading requirements, are now seeing what we call thermal cycling. This means that the valve and all of the components are heating up and contracting, heating up, cooling down. And this places a lot more stress on all of the equipment. It basically is placing a greater demand on the valve itself. With a greater demand on these type of plants, this brings into focus the maintenance of these types of equipment. So what does a repair kit look like? What we're proposing is a pre-assembled kit that eliminates rebuilding components in the field. The key advantages of this is when you're in the field, we have very competent people, whether they're at site or whether they're contractors. But the downside of that is a lot of folks are not necessarily familiar with each and every OEM. And every valve manufacturer has a different way of assembling valves or even manufacturing them. And so it is possible for valves to be put back together in the field, but maybe not in the right way. And that could cause some issues further down the road. What we're proposing is a fully built repair kit that is done with OEM quality. And so when it's done in a factory, there's certain procedures and processes to be followed. And of course, this is being done day in and day out. So it's a very repeatable process that we're talking about. What this also means is that if we have a kit that can be replaced in the field, and that kit is what we call the V-core, it also means that for the second time around, if any maintenance is required, rather than having a brand new kit, it could be sent back to either the OEM, or the manufacturer, or an authorized repair center such as CGIS, and that would further reduce the cost of ownership. So basically, the V-core is a two-piece kit. We have what is the end cap on the left here, and we have the body of the valve here on the right. But the two components together form the core of the valve. So how does it fit in line? We look at these two pictures here. We have two symmetrical components here, which really is an adapter that fits onto the pipe. So for the first installation and the first installation only, there is a weld. So we have either a socket weld or a butt weld that goes onto the pipe itself. And at the end of that adapter is where the V-core actually fits. So we have two of these adapters that fit there. And if we overlay the V-core kit, this is what the entire package looks like. So basically the V-core slides into place between the adapters. We have bolts that complete the installation, and really disassembly is the reverse, where the bolts can be removed in line and the V-cores replaced or rebuilt for whatever is required. But the point here is that once we have the adapters welded in, it's a once and for all situation, and no more welding has got to be incurred. And that's where all the savings come throughout the life cycle of this particular design.
Hey, Richard, just real quick, we had a question that says, only for the valve port threads, do you local heat treatment to increase hardness? Or do you locally heat treat
Yeah, so the
valve
heat
port
treatment,
threads?
yeah, so generally speaking, if for the first installation, we can supply the valve as you've got there. So this shows the four components to it, but for the first time, it'll be supplied together as a single kit. When it comes to post-weld heat treatment, what we advise is, if you can see my cursor, once the insulation is done around the whole valve, this flat portion here, we would give recommendations in the installation operations manual not to exceed the installation above that level. And the reason is that we want to allow the internal components not to be overcooked. And that's very, very critical. The other way of doing this, and one of the advantages of the V1R, and you couldn't do this with the V11, is that the welding could be done firstly on the ends, and then the V-core slid in. So you reduce the possibility of overcooking the internals. So that would be the recommendation when it comes to post-weld heat treatment and avoiding overheating components. So let's talk about the sealing seat. So we talked about the V-core having two components, an end cap and a body. And this is where ValvTechnologies has taken everything it's learned about severe service metal-seated ball valves over the years and used all of that technology and applied it in this package. So what this does mean is that we continue to use an integral seat. It's a key feature or key differentiating advantage of the V series compared to other manufacturers out there. And why would you want an integral seat? So an integral seat means that it is part of the end cap. So it's not separate, it's not loose, it's not pressed in, it's not even welded into place. And so having an integral seat means there's no leak paths behind that seat. So when it comes to steam generation, it means that we make sure that all the steam stays within the valve, that it doesn't escape, because steam losses do equate to efficiencies overall. So ValvTechnologies has taken its flagship integral seat design and continued it on the V1R as well. When it comes to body sealing, we are pleased to introduce a triple body seal arrangement. So we have a body seal between the V-core itself, so the end cap, and the body of the V-core. And now we have body seals that fit between the V-core on either side of the V-core and onto the welded-in adapters. So it's a triple body sealing design. So these aren't gaskets, these are metal, 100% all metal, solid metal that is used to create that seal. And these are technologies that we've developed again over the last 30 to 35 years. And typically for high temperature applications, so those where we're exceeding 1000 Fahrenheit, about 500 Celsius, the materials that we use will be Inconel 718, which is a high performance material for these types of application.
And Richard, just to confirm, this is the identical part that a current V1 user would have seen in the past. It's not a new seal design. It's the exact same technology, the exact same part, in fact.
The exact same part, to the same OD, the same ID, the same thickness, the same material specification. So we are carrying that through from all the past designs that we've had.
Okay.
On the hard facing, again, ValvTechnologies is continuing what it's developed over so many years. The last iteration that we did was about 12 years ago when we changed the composition of our chromium carbide, and we're maintaining that for the V1R. So chromium carbide would be 75% of that, and then the binder is a 25% nickel chromium binder. So the coatings are the same chemistry. They have the same high mechanical bond, so they exceed 70,000 kilopascals. And it's fair to say that we've now amassed over 1 billion operating hours when it comes to hard-facing technologies. So originally this came from the aerospace industry back in the 60s. We first started to do this in the early 1990s, and then we advanced the technologies, brought these in-house, and started to do these robotically in around 2012, 2013. And that's what we're continuing to do here going forward. The chart just shows or compares chromium carbide versus other well-known hard-facing materials such as alloy 6, which goes by the trademark of stellite. The important key factor here is the temperature. So all materials get softer as the temperature elevates. So if we look at the chart here, we can see that once we reach about 800 Fahrenheit, that the hardness of alloy 6 drops off more rapidly, whereas with chromium carbide, it maintains that hardness. And it is the temperature that's becoming more and more important, especially with all the newer design combined cycle plants out there. Higher temperatures and pressures equate to greater efficiency. So maintaining hardness at elevated temperatures is still a key factor as well. When we look at the spring technologies, the way that both the V series and the V1R seals, again, are identical. So we use ultra high forces to push the ball into the integral seat. And so we don't like to use the word it's a floating ball valve, because a floating ball valve implies that the ball can move from left to right. And once the ball is able to lift off the seat, then leakage can occur. So what we say is that we apply extremely high loads horizontally to make sure that the ball never lifts off from the seat. So you can think of it as a valve that acts like a trunnion valve, but it's actually not a trunnion valve. So of course, a trunnion valve has an upper bearing and a lower bearing on that ball to keep it fixed. What we're saying with the ValvTechnologies approach is the forces applied are so great that lateral movement cannot occur. And so one of the advantages of that is because we don't have any trunnions, there are no floating seats, which is, of course, how a trunnion valve actually works. So what this means is if we look at the picture here, we have the high pressure end, typically on the right here. The bevel spring, so it's not a waved spring, it's a machine from solid, and it looks more like a washer. That's there depicted in light blue. And the integral seat there is shown in the red, with the red arrows there. So this mechanism means that we can have ultra high pressures on the right hand side of this drawing here, but it means that there is no leakage that occurs downstream, which is in this diagram onto the left. The spring technology are all the same. So really, all we're talking about here is rapid serviceability. So it's the speed and the ease of popping in and out of V-core whenever maintenance is required. The advantage is it's no more cutting valves out of line. So once the first V1R is installed, there's no more cutting of valves out of line. So that's a cost saving there. There's no more welding, and that's where the biggest savings occur. There's no more rebuilding on site. Is not to say that this cannot be done. They can be done on site. But if you're rebuilding components in a factory or perhaps in an authorized repair center, it is more cost effective to do it that way. If you think about it, if you do field service repair, all the people, all the tools, all the equipment must be brought onto site. In some cases, we might have trailers there where we have small lathes aboard that particular trailer. And so it's much more efficient to have the components flow through a factory where you have all the equipment and all the tools already in the production line. So not only is it quicker to do under a factory environment, it's also a lot more precise, it's a lot more controlled, it's a lot more repeatable. And so the idea of not doing a rebuild on site leads to better quality, and it also leads to lower costs. With all that in mind, ValvTechnologies is still continuing its legendary 4-year zero leakage performance guarantee. So what we're saying is on the V1R, we're not talking about a standard parts and labor warranty. We're actually guaranteeing that the valve will not leak in the first 4 years in any steam application. And there's no other manufacturer out there that's willing to do so, particularly with the high thermal cycling that we're now seeing out there. When it comes to repair time, we can get it down to 90 minutes. That would be the quickest. And again, that is relatively quick given the time it takes to do post-wall heat treatment when replacing valves. So 90 minutes is about the quickest. Obviously, that time would increase as the valve gets older. As it's seen many more thermal cycles, we would expect that 90 minutes to increase somewhat. So how do we have all the tools to do this? There is a sidewinder pipe spreader available. It's available on the open market. But what this picture here shows is we have the valve obviously being held in the middle. It's supported by 2 sets of chains, as chains are easier to hold pipe and valves. They clamp each side of the valve. And what's not clear on this picture, but if you look on the uppermost part where my cursor is, just around here, this bit here is movable. So you can see it's got different holes here. So you can have different lengths of valves. But inside this tube here, there's actually a screw jack. And on the very end of this, you turn that around. And what this is doing is that it's pulling the pipe apart in this direction. So we're not actually deflecting the pipe like this, into and out of the photo. We're actually pulling them apart. And we do need a minimum of 1/4 inch clearance for the V-core to drop off once the bolts are removed. So we really have these pair of chain clamps and that tubular arrangement there, the drive screw right at the very upper part of that photograph. And the operating spans would be up to 42 inches, which would be way more than what we need here. And the amount of force that could be applied would be greater than 2,000 kilograms, which would be more than enough for these particular types of applications. And again, the types of sizes that we're looking at when it comes to steam valves would be typically 1 inch, 1.5 inch, 2 inch, 3 inch, and 4 inch. So this type of equipment will be much more flexible, or have the flexibility for all these types of sizes of valves. So continuing on with our little F1 theme in terms of rapid serviceability, we have a little racetrack here just to explain how the service model works. So if we look at the checkered start line, we decide that there's a need to replace the V-core. The first thing that can happen is you go to your local distributor. So in Canada, this would be CGIS, and CGIS would be there to supply the new V-core. The service begins at the power station or the steam plant. It's a slide in and a slide out event, so it should be done relatively quickly. And then once the replacement V-core has been installed, the previous one can then be returned for refurbishment. The advantage of doing it this way is that during any outage or turnaround, you're always up against time. Time is the key thing here. And so once the new V-core is installed, the previous one does not have to be refurbished in a rush. And this is where we can eliminate such things as expediting fees. So it could be returned to the authorized repair center, the ARCUS we got here on the picture, of which CGIS is the ARC for Canada, or it could be returned to the manufacturer ourselves for a full rebuild. So if we take an example, if let's say there's 10 identical valves, it's not recommended to have 10 V-cores. 1 or 2 will be more than enough. And so once one comes out, it can go back for refurbishment, and then it can go back onto the shelf for any future repairs that may be needed. So that V-core can be returned back to the end user for future use. So that's the new service model of the V1R, which was not possible with the V11s. The intent of the original design V11s was that they were just welded into place and you set and you forget. So really, let's just summarize what we've gone through. So we're really talking about a perfect product installation every time. We're combining the best of field repair with factory precision and speed. We remove the effort of the field service technician and all those costs associated with it, because these are severe service valves. As Dave mentioned right at the very start, the severe service market is different to the general purpose or the fit for purpose market. And so what we're doing here is we're taking a complex piece of engineering and we're simplifying how things go on in the field. So it's a simplification of the repair process. And so we also have the factory economies of scale on the V-core. If you think about doing a rebuild on site, the service tech may be very skilled and very knowledgeable, but it's still going to take longer in terms of number of minutes to do a rebuild on that site. Certain tools might be missing and you have to wait for that to arrive. Certain components which may have been unforeseen might have to wait an extra day or two for that to arrive. And so we have those economies of scale in building many V-cores under factory conditions, which of course gives us a repeatable precision. So with all that in mind, before we go into the questions, what kind of applications do we think are most suited to the V1R? And if we think about the way steam plants are being operated nowadays, there's a lot more thermal cycling. So components are heating up, they cool down, there's expansion, there's contraction. And so wherever we have a relatively high cycle type of application, that's a very good fit for a V1R. And perhaps one of the most cycled valves in any steam system would be the temperator block valves. It's a very tough service for any manufacturer to achieve. With ValvTechnologies, we still stand behind the 4-year zero-leakage warranty, performance guarantee. So we know that the first 4 years will be trouble-free. But when it comes to high cycling, these do place greater demands on these types of valves. Other high cycling applications would be desuperheated blocks for feed waters. Wherever we have any frequent throttling, so blowdown valves would be another good example. HP superheated drains, before and after seat drains, and anywhere where we have main steam isolation will be another good application. So one of the advantages of the V1R is we can now start to look at throttling conditions. Even though this is not a control valve, it is possible to use a block valve or an isolation valve for certain throttling applications, and the V1R would fit that very, very nicely. So before we wrap up and go into the questions, we just have a little video here, a little 90-second video, which shows V1R. Great. Well, that's all I've got. And what we'd like to do now is open up the floor to any questions that you have.
Yeah, perfect. Thanks, Richard. One question that came in was, what is the available valve size range? And might as well add in pressure class as well to that.
Yeah, good question. So we start off at 1 inch, 1.5 inch, 2 inch, 3 inch, and 4 inches. So the bore sizes would start from 5/8 bore and go all the way up to 2 1/8 bore. So be four course sizes of valves there, or body sizes.
Richard, in terms of end connections, though, I know that we can take that smallest valve and we could build down to 1/2 inch. And in fact,
Yeah.
we've even done some smaller 1/4 inch designs for some customers. So we can modify that end, correct? The weld end down?
You could,
Yeah.
yeah,
Yeah.
you
Okay.
could.
Thank you.
Yeah, in all fairness, that would be the minority rather than the majority. But yes, you would be able to
Yes.
get down to 1/4 of an inch as well.
Okay. Another question was, you noted the V1R has less customization options available. Can you elaborate on what those limitations are?
Yes, so at launch, there's 3 material types. So F22 and F91, because again, we're trying to avoid post-weld heat treatment. There is also A105, but there is no stainless. So stainless is not an option, or any of the exotic metals such as Inconels will not be available on the V1R. So 3 main material sizes.
Okay. And what would be a typical change in end-to-end length between the V11 and the V1R?
That's a very good question. So one of the advantages of the V1R is it really addresses the aftermarket. So when EPCs construct a new design plant, everything must be done to a set face-to-face standard. So all manufacturers, conform to the ASME B1610 face-to-face dimensions. The V1R does not conform to that, but it does have an advantage. So if you're removing a defective valve to begin with, you have to cut that pipe. And so in cutting the pipe, it's more useful to have a replacement that is slightly longer. So it depends on the particular size, but if you judge for the length of the V1R to be about 25% longer, then that would be a good starting point. So it is fair to say it is longer, but the advantage here is that as you've cut the previous valve out of line, you don't have to weld back in so much pipe to begin with on the first installation.
Okay. Got another relevant one here. Do you supply these V-Core valves for nuclear applications and non-severe service or conditions?
Yes. So the procedure is very different when it comes to nuclear. So the site has to be nuclear certified for the N-stamp. We do have an N-stamp certification for our factory in Houston. It just means that the procedure will be slower because we have a lot more hurdles to overcome. But yes, is the answer to that question. The V1R can be supplied into nuclear applications. It just means that the lead times are a little longer.
Okay.
In terms of non-severe, sure. If you're trying to put a fit-for-purpose valve in a severe service application, that typically doesn't work, but it's not true for reverse. So you could use a severe service valve in a non-severe service. So yes, you could go the other way.
Perfect, thanks. And this is a pretty good segue to the next one. Can you please specify the industries where these valves are useful?
Say anywhere where there is steam generation, of which we have fossil power, nuclear power. We even see process steam applications in the oil sands facilities as well. So I would say anywhere where steam is involved, whether it's for power generation or for process steam in a given plant.
But Richard, there's nothing that would preclude us from using it on any high temperature gases, or not even high temperature, just any gas service as well.
That's correct.
Right.
Yeah,
I mean, You know, the one thing that struck me, Richard, I see another question came in about the sealing, and we talked about the coatings, but it just struck me that perhaps everybody's not 100% familiar with the whole concept of the integral seat, the ball, the critical use of the coatings in the design. And if I could take 30 seconds, Sam, if you want to go back to that slide that showed the axial flow or the axial lock, I think it's interesting. There was a question about the sealing seat of the valve. So as the red arrows indicate on the left, the integral seat is part of that intermediate end cap. And when we build that, the seat in that integral cap, as well as the ball, have the HVOF coatings that Richard talked about earlier applied to their surfaces. Okay, so on average, these run 66 to 69 Rockwell C for the materials that we're talking about. And we take those two components and we mate lap those components together during manufacture. When that process is done, you can't even get small molecule gas between there. So we have quite literally thousands of these valves on hydrogen isolation. We've got them in, we've tested them on helium circuits and other gases, and those two become a matched pair. When we assemble the valve, so we put the body and the integral seat together, that Belleville spring that's light blue, along with what we call the guide or support seat, place a very large load on that ball and force it onto the surface of the seat. Now, those two components for their lifetime are now mated. And we cannot get anything. That ball never leaves the seat. So the blue ball in the middle only rotates in its own space, its own geography, if you will. And why that's important is this valve is exceptional on solids. And in this particular case, when we talk about steam, and we do a fair bit of work in the SAGD industry, where you've got what is dirty steam. So you might have 80% quality steam. So you've got water molecules traveling at extremely high velocity. When this valve is closed, we cannot get anything at the seat. Okay, so the seat is fully protected in the closed position. When I rotate the valve from closed to open, the ball is always in contact with the seat. So it never leaves there. I cannot get material in between the ball and the seat. And when it's open, it is virtually a piece of pipe. So the seat is fully protected for the lifetime of the valve, except when we're rotating from open to close and close to open. So if you can imagine for a moment a valve that sits there for 10 years, so what does it cycle? 1,000 times, 100 times? That is the only time that the seat is ever exposed to process. If you compare that to a gate valve or a rising stem valve, when those valves are open, the seats are fully exposed and therefore they are damaged throughout the process life. This valve, it's fully protected through the process life. So it's one of the key, very small things that we don't perhaps think about all the time. So A, we present extremely hard surfaces and we fully protect the seat throughout the life of the valve. I hope that makes sense.
Perfect. Thanks, Dave. I believe this question is fairly relevant to what you just said, but I'll ask it. For valves from 316 material for hydrogen applications, do you locally heat treat on valve seats or port threads?
Do we locally heat treat?
Do you locally do heat treatment? Sorry, misread.
So on 316, we would only offer 316 on the V11s, not on the V1Rs. If they're welded in place, then yes, there would be some post-weld heat treatment required during the welding process.
Okay. We've got a couple questions on cost that I'll try to amalgamate. Can you provide an approximate % change in price between the V11 and V1R? And then tacking on to that, what is the cost comparison between the V1R and V11 valves compared to other standard or fit for purpose valves in the same kind of application?
think it's fair to say that the V1R is priced more than the V11 upfront because the total costs are less. So really what we're doing here is that we're reducing the cost of welding in and out of line in the future. So because you have a valve that is longer to begin with, there's more material, there's more mass. Yes, it's going to be a little more expensive than the V11 to begin with.
Okay. And I think they're looking for just kind of like rough comparison to, say, a competitor fit for purpose valve or something like that.
I would probably start at about maybe 25% more.
Okay. Do you have a CRN for all provinces?
Yes, so Alberta was the first, and that was granted recently. And we're in the process of wrapping up from all the other provinces that require it. The first province always takes the longest, the rest just look to each other. So the answer to that question is yes, we will have all the CRNs.
Perfect. And then one more, it says, I see the advantage in welded connection. Would you use the V1R with flanged connections?
No, so the V1R is not available in flanged ends. For that degree of customization, we'll have to look at the traditional V11s.
Richard, can I just ask, we sometimes get requests for, we do commonly with the V1 series, a weld by thread connection. And typically people are using them on instrument isolation points in some services. Would you anticipate that we could do a socket or butt weld inlet, and on the outlet side, we could take the adjacent end cap and use a blank end and tap that to whatever was required?
I think it could be done in an aftermarket type of mode.
Okay.
Be done at the factory level, not at this stage.
Okay.
Maybe at a later point, but to begin with, no, it's a lot of standardization to start off with.
Understood. Thank you.
Maybe for the next 6 months, that'll be the V11s, if that requirement is there.
I think that's about it for questions, unless anyone has anything else. One question that I had actually was, does ValvTechnologies have any other product lines that you're considering adopting this plug and play approach to?
There's only one other product that is already inline repairable, and that's the parallel slide gate valve, which is called the Isotech. So that is also designed to be welded in, but because we've taken everything that we know on spherical surfaces and created a flat version of that type of valve, that product range, the Isotech, is inline repairable. So that works differently, whereby the top yokes, the bridges, the bonnet can be removed, and even the discs replaced inline without having to cut the valve out. But at this point, when it comes to ball valves, it's just the V1R and the Isotechs that are inline repairable.
Okay, great. I don't think we have any other questions, so if you guys have any last comments, feel free to wrap it up.
I just want to thank everybody for their time today, especially Richard, obviously. So thank you, Richard, for your presentation today and for your work in the development of this product. We're super excited to add it to the CGIS offering, and we know that our customers across the country will be excited to see the new technology that we'll be pushing out over the next several months. So thank you, and thanks to all the clients online. I see a number of familiar names, so thank you for your time today and joining us. We know how valuable that is. So everybody continue to stay safe, and thanks very much for joining us.
All right, thanks a lot, everyone.
Thanks, everyone.